Scientists have long assumed that when visible light hits an electron inside matter, the latter will instantaneously start wiggling at precisely the oscillation of the electric field of light. These ultra-fast movements happen at nearly 10 to the power of 15 times a second. This feature of electrons has inspired a new era of scientific exploration that could impact the electronics of the future. Conventional electric fields created by batteries or other typical electricity sources could be replaced by the electric field of light. This possibility could speed up electronics, thereby speeding up data processing some 100,000 times in comparison to what is possible today. But do electrons inside matter really respond to light instantaneously? Or does it take time for an electron to react to the forces of light? Quantum mechanics predicts that even these extremely small and light particles of the nanoworld, when residing inside atoms, molecules, or solids, could become lazy and refuse to react instantaneously to fields of light. They instead need time, somewhere in the order of attoseconds, to respond to the force of light. 1 attosecond is a billionth of a second. To see this lazy electron behavior, one has to drive them extremely quickly. Now, scientists from the Attoelectronics Research Group at the Laboratory of Attosecond Physics at the Max Planck Institute of Quantum Optics have achieved the first visible light flashes lasting just 350 attoseconds. To create these extremely short light flashes, dubbed optical attosecond pulses, Eleftherios Goulioumakis and his colleagues developed an advanced apparatus called a light field synthesizer. This can divide visible laser light into different color bands in the infrared, visible and ultraviolet parts of the spectrum, and put them back together after controlling the properties of each band individually. With this device, laser pulses can be shortened to around half an oscillation of light. It has enabled the scientists to achieve enormous, never-before-attained control over the properties of light.
With this technology, we are now sure that we can exert precise forces on electrons inside matter and explore their dynamic properties with an accuracy never before possible.
To see how quickly electrons would respond to these extremely fast flashes, the scientists illuminated atoms of krypton with optical attosecond pulses to set electrons in motion. These electrons are shown here as a green cloud around an atomic core. The physicists then measured the ultraviolet radiation the wiggling electrons emitted in a vacuum. They repeated this experiment many times, each time with an optical flash, which applied a slightly different but precisely known force to the krypton electrons. From their measurements, they concluded that electrons take approximately 100 attoseconds to react to forces of light. These new findings comprise the first measurement of the response time of electrons on the atomic scale, with the results now being published as a paper in the scientific journal Nature. In the future, the scientists plan to extend their approach to controlling electrons in solids and study important processes such as how electrons interact with each other in complex systems and how quickly we can turn electronic currents in solids on and off. These studies may pave the way towards exploring the absolute frontiers of future electronics and photonics.